Anujan S talks on refinery technology, which include processes, process equipment, and also oil economics.
This presentation we will discuss the concept of override, which is very popular in hydrocarbon industry, and we will explain it with the help of implementation in an FCC unit. This slide explains the concept of override. A control valve will take signals from two controllers. One is a normal PID controller which normally runs the unit. Other will be from a safety control loop, and this will be a fast acting controller. In case of any impending safety issues, the output from the safety controller will be selected by a selector switch and overrides the other signal. Hence it is called the override controller. As the safety controller is it has got a high gain control, the valve immediately closes to avoid any safety problems in the plant. This gives the schematic of FCC unit. Reactor gets feed from the bottom, and this catalyst will fall into the regenerator through a standpipe, and this flow is controlled by the spun catalyst slide valve. And when the catalyst reaches the regenerator where air is there, the coke is burned off and the catalyst is returned to the reactor bottom, that is the riser bottom, through another standpipe, and this flow is controlled by the regenerator catalyst slide valve. Since the reaction temperature is governed by how much catalyst is going into the system, the regen catalyst slide valve is configured as the temperature controller of the system, and since we withdraw catalyst from reactor through the spun catalyst slide valve, this valve is configured as the level controller of the system. So the regen catalyst slide valve moves catalyst from regenerator into the reactor bottom, and this supplies the heat of reaction, and hence the temperature is adjusted by this catalyst flow, and hence this valve is configured as the reactor temperature controller valve. The second valve is the spun catalyst slide valve, which is on the line from reactor to the regenerator. When this valve opens, the catalyst is moved from reactor into regenerator, and hence the level in the reactor changes. Hence this slide valve has been configured as the level control valve for the reactor. Now let us discuss the emergency situations in the plant. There is a very delicate pressure balance existing between regen and reactor. There can be cases where the pressure, suddenly there is a pressure change which can upset the pressure balance. In that case, hydrocarbon can come to the air side or air can go into the hydrocarbon side, which are very dangerous situations. So the slide valves in this circuit also have a dual role to play. In such cases, these slide valves, they forget their normal temperature and level control roles, and they immediately take a close of the lines, preventing air entering reactor and hydrocarbon entering the generator. This schematic gives the override system for the regen catalyst slide valve. The catalyst flows from regen into the reactor bottom, so the pressure upstream of the valve will be always higher, and the signal to the valve actually comes from the temperature controller. But before this reaches the valve, there is an instrument called low signal selector, which gets a signal from the differential pressure controller also. And this low signal selector selects the lower of the signals, whether it is temperature control or the differential pressure controller, the lower one will be selected and that goes to the slide valve. So, apart from the temperature control signal, the low signal selector gets a signal from the differential pressure controller also. Since the setting of the differential control valve and the actual value will be a lot of gap and the value will be much higher than the setting, this controller will send a very high signal out. So the low signal selector will automatically select the temperature signal and your normal PID control action will be effective. But when there is a pressure upset, the delta P across the valve reverses. In that case, there can be a flow of hydrocarbon into the regenerator, which is very dangerous. So in that case, the valve should immediately close. So in this case, the differential pressure controller will sense this dP going down below the set point, and in that case the signal will be coming to 0, and that will be selected by the LSS, and hence the valve closes immediately. Thus a major crisis in the plant is avoided. Here is a schematic for the override control for the spent catalyst slide valve. This valve gets two signals, one from the reactor level controller and one from the DP controller across the slide valve, and the low signal selector selects the lower of the signals and takes action. Explaining the schematic, the spent catalyst slide valve signal is coming from a low signal selector. There are two signals coming. One is from the level controller of the reactor and the other is from the differential pressure controller across the slide valve. Normally, due to the head of the catalyst in the reactor, the output from the DP controller will be very high, and hence the low signal selector will be selecting the signal from the level controller, and hence the action will be a simple PID controller's action. When suddenly a pressure upset comes, the differential pressure reverses and there can be a chance of air entering the reactor. And this differential pressure coming to close to 0 will be immediately sensed by the differential pressure controller, and the output will suddenly go to 0. This output will be sensed by the low signal selector and it selects the 0 signal, and then all of a sudden the valve closes, averting a mishap in the plant.
Before signing off, I have a few requests. If you like this video, please press the like button and also share this video with your friends so that they also can be benefited. If you have any comment on this video, please drop a line in the comment section just below this video so that I can try to incorporate in the future versions. Also, do subscribe to my channel so that you get immediate notification whenever I upload similar videos in the future. Thank you.